Okay, so we're going to solve 6c, which is y is 1 plus x squared to the minus 1/2. Oh, this is in 1.2. So y is the quantity 1 plus x squared to the minus 1/2, and y double prime is a whole bunch of garbage. X squared minus 1 times y minus x times x squared plus 1 times y prime, all over x squared plus 1 quantity squared. And y of 0 is 1 and y prime at 0 is 0. And what was I supposed to do? Demonstrate that that solves this?
And satisfies the initial
And satisfies the initial conditions.
Yeah.
Okay, let's check satisfying initial conditions. Wyatt, what does y of 0 equals 1 mean?
That means for when you plug in 0 for x, y equals 1.
Good, so let's check. So y at 0 is 1 plus 0 squared to the minus 1/2, which is 1 to a power, which is
1.
good. Check. Okay.
Next one's mine, probably.
All right, we're good on that. I don't know. Wyatt's had some calculus, right?
Not in like 3 years, but I mean.
Okay. If that's a function of x, can you differentiate this crap? So what's y prime?
You're still asking me?
Uh-huh.
I'm confused.
When you got stuff to a power, what do you do with the power?
Yeah, put it to the front, don't you?
Yep, good. Put it to the front, take the stuff to the
Plus,
close,
minus 1.
minus 1. So minus 3/2, and then you need the,
Then you add something there.
no, you multiply by something. But it's the,
The chain rule.
yeah, you need the chain
Oh,
rule, so you get the
chain rule.
derivative of the inside. Comes right back, right?
Yeah, I remember the chain rule.
Alright, so then we can slash it 2 here, and we can maybe simplify a little bit. So we got minus x times 1 plus x squared to the minus 3/2 for y prime. Okay, and then I need y double prime. So on this I need the y.
Well, can't you do your other condition first though?
Oh yeah, I should check the other condition. Alright, so y prime at 0 is minus 0
Times something.
times some shit.
So 0.
Is 0. Cool. Alright, to do the second derivative, I have some stuff with x's times some stuff with x's. So I need the, what rule?
Chain rule.
No.
I don't remember. You take it.
What do you call multiplication? What's the math dork word for multiplication? So, starts with a P.
Inverse quotient.
Product. So you need the product
Rule.
rule. So you do the derivative of the first thing times the second thing.
Oh, I remember this too.
Yeah. Plus the
Derivative of the second.
derivative of the second thing times the first. So minus x times, and then I need to take the power down, 1 plus x squared to the 1 lower power times,
2x.
good, derivative of the inside. Beautiful. And then you can simplify this a little bit more.
We're gonna want to.
So you got a minus 1 plus x squared to the minus 3/2 plus 3x times 3x squared times 1 plus x squared to the minus 5/2.
Yeah. That looks annoying.
Okay, so I got that thing. And in theory here, I'm supposed to check that y double prime, i.e. this shite here, is equal to that other thing. So I'm going to start with the right-hand side and see if I can get it to be that.
Please.
So I got a x squared minus 1 times y times 1 plus x squared to the minus 1/2. Then I have a minus x times an x squared plus 1. And then y prime
Is negative x.
is negative x 1 plus x squared to the minus 3 halves. And then this whole thing's supposed to be over x squared plus 1 squared.
Yeah.
Okay, cool. So, let's see. And I'm supposed to get lots of 1 plus x squareds on the bottom.
Yeah.
Okay. So let me simplify this crap first, I guess.
Yeah.
So that's a x squared minus 1 times 1 plus x squared to the minus 1 half plus x squared times 1 plus x squared to the minus 1 half. That's
Oh my god, what?
maybe I'll put that as 2 over 2.
Can't put that in second.
And then on the bottom here, I've got an x squared plus 1 squared. Okay, cool. And then I'm going to factor one of those to the minus 1 half. So,
Yeah.
so I got a 1 plus x squared to the minus 1 half times x squared minus 1
1. Or, yeah.
plus x squared, I guess.
Yep.
All over x squared plus 1 squared.
Those can combine.
And then that's this guy really belongs down there, right?
Yeah.
So I think I got
3 halves.
2x squared minus 1 over x squared plus 1 to the 5 halves.
3 halves. Oh.
Because 2 is
Yeah.
4 halves,
Yeah. No, I
plus
thought.
1 half
I
is
thought it was
5
a triangle,
halves.
Yeah.
And then, let's see. Oh yeah, and then I have a little bit of massaging that I could do to this side.
I added the fractions.
Yeah, so if I massage this side a little bit, maybe I'll just do this. So I say, alright, on the left hand side I have minus, and then there's a 1 plus x squared to the minus 5 halves there, almost. Well, except there isn't.
Right.
So I really have only minus
Multiply
3
by
halves. So
1
I'm going
plus
to
x.
multiply by 1 plus x squared.
Yeah.
And then over here I got a plus 3x squared times 1 plus x squared to the minus 5 halves. And then I'm going to factor a 1 plus x squared to the minus 5 halves out of that. And then left in there I have a minus 1 minus x squared plus 3x squared. So, check, check. Those are the same. Because 3x squared minus x squared is 2x squared. So 2x squared minus 1.
Yeah. 3 minus 1. Thank you.
Yeah, no problem. It maybe would make life a little bit easier. I showed you guys this kind of like shove it in the right hand side and massage the right hand side.
Yeah.
It maybe would be easier in general to do the, suppose that this is a solution, plug it in with an equal sign, use algebra, right?
Yeah.
And then if it reduces to 0 equals 0, you're set, and if it reduces to anything else, you're not. The reason I don't like to do that,
Because it's not really kosher.
well, it's just when students get to this. Right, when
Why
students
0?
get to x squared equals 0, they're like, cool, I'm done,
Right.
x is 0.
Not identically, so it's not.
Yeah, but those aren't identically the same functions, so, yeah.
Okay.